In this question, we are asked to use MacLauren series to find the expansion of x plus 5 to the power of 4 to the fifth term. As before, we could use the MacLauren series to develop a power series for the function x plus 5 to the power of 4. So we need to differentiate this a number of times to give us the coefficients in the series. Now, to differentiate this, we could use the chain rule, and when we differentiate, we get 4 times the bracketed term to the power of 3, and then differentiate inside the brackets, we just get 1. So this will be 4 times x plus 5 cubed. Now differentiate this again, which will give us 4 times 3 times x plus 5 squared, again by 1. Differentiate again, we get 4 by 3 by 2 times x plus 5 to the power of 1. And finally, differentiating one more time, we get 4 by 3 by 2 by 1. Take 1 from the power, we get 0. And any number to the power of 0 is 1. So that's just going to be 4 by 3 by 2 by 1. We now substitute x equal to 0 into each of these terms. So to get f0, we substitute 0 for x, which will give us 5 to the power of 4. We now substitute 0 into the first derivative, and this will give us 4 times 5 cubed. And do the same for the remaining derivatives, will give the following terms. We now substitute these values for f0 and the derivatives in the MacLauren series, and that will give us the following expression. And if you use your calculator to calculate these values, we get that x plus 5 to the power of 4 is given by this expression here. So next, you could stop the video and try this question, where you're asked to use the MacLauren series to show that the expansion of x plus 3 to the power of 4 is given by this expression here.